So the first one is motion amplification. This was absolutely amazing. This is the core of the product, where we can actually see the motion of the machine that's not visible to the naked eye. And as you can see here, it can expose problems such as a cracked base, anything like that. Next up was displacement frequency measurements. We can draw an ROI, region of interest, anywhere on the image and get a spectrum and waveform data. Stabilization, the camera likes to be on stable ground, but if we do have issues with that, we can use software stabilization to reduce the effect. Frequency-based filtering, this is awesome. We can actually look at an individual frequency and actually filter out the rest of the vibration and only have a resultant video of that frequency. You can see here we've got some screens and a pump, and we've filtered just for the pump frequency, and when we press play we can actually see the motion just from the pump itself, and the screens behind has been removed. Here's another example, a motor and a fan showing you the vibration from each frequency. Motion Explorer, a bit like a vibration database management system, really useful for managing your files and again transform the way we use this system. Annotations, this was great, especially for reporting, where we can actually draw ROIs and then pull out live plots from the data, orbits, look at a bit of phase data between each point as well. Really cool tool. Shaft inspection, this was another feature where we could actually use the camera's capabilities to slow down motion and inspect items of rotating plant. Here we've got some belts we've slowed down, we can actually inspect the pulley, and then also we can inspect the belts, and here you can see the belts are slipping. Shaft measurement as well. This is where we can actually draw an ROI on a certain part of the shaft, horizontally or vertically, and actually get a measurement of run out very accurately using from the time waveform. You can see here we've done it across a coupling. When we look at the time waveform data, we've got an accurate measurement there. So that's another useful tool. So next up is relative phase measurements. This is where if we've got a couple of ROIs, we can compare points across each other. If we enter the speed and set one of them as a phase reference, we can actually see the relative phase between the 2 points. First up is live motion amplification. This is amazing, and it's going to transform how we use a system in the field, because it can give us instant amplification. As you can see, we were in acquisition, we click one button and we've got live MA. We feel this will be really useful on pipework applications, where we can do lots of scanning and see where the vibration is in the field, but it'll have lots of other uses as well on lots of equipment. Motion vectors, this is where we can draw ROIs and actually get a representation of the amplitude and phase and the direction of motion between points. So I'm going to activate this here, and we can see the arrows show the direction of motion and the amplitude. Really visual method. We can have amplification on or off for this, it doesn't matter, but it works really well. You can see here we've got a pump twisting and bending with some pipes, and you can see the direction of the forces and amplitudes. Makes it really clear. My friend Andrew, colleague Andrew here, is playing with a Lamborghini. As the engine revs, we can see the direction of motion, and when we couple that with another view of the outside of the car at the same time, you can see how the body moves. So we should have some great applications for these vectors. Next up is transient ROI motion track. This is unreal. We can now basically, in the software, we select a transient ROI, and then we actually draw a box around the region of interest, and the software will automatically calculate the motion path for that part and subsequently give the time waveform data, we can get spectral data, so we can actually get vibration across a moving part. Here's a staple machine, we're tracking the motion, we've slowed it down, and again, as well as the path, we can actually get the vibration whilst moving, which is just unreal. This is one of my favourites by Keith, helicopter coming in, and we're tracking the actual vibration and motion from it, which is just unreal. We can do it on multiple regions of interest, ROIs. So a lot going on there, but we can do it from different sources. So another transient capability is we can actually do moving objects with large motions now. You can see this rocking there. Before, this wasn't possible with the standard motion amplification. You can see on the left that sort of ghosted, and on the right it's worked really well. You can see here it again on this digger. We can actually see the vibration motion whilst it's doing large movements. Motion map. This is a new tool, a new feature where we can actually look at different frequencies and actually have a colour, almost like a heat type diagram, but for vibration, where the high and low vibration is. Here we've got a couple of screens. We're going to set off the motion map, and you can see we've got a spectrum, and I can identify an individual frequency, mark that, and then we can adjust the slider scale to actually show the vibration from different areas. So we've got high and low vibration levels represented by the colours. We change to a different frequency, and we can now see where this vibration has been transmitted. So a really cool tool, again very visual. We've also used it a lot. It works really well if you use a single colour. Mark the frequency of interest and then adjust the threshold, and it can actually show you on pipelines and areas where you don't want high vibration, which areas have got the problem. That works well. You can also add a bit of amplification in there and press play and record these videos if you use a bit of transparency in there. So here's some examples. This is again a pipework one with high vibration. Gives some good feel for the system, but we can also use it on machines as well. Let's start with triggering. So this is a fantastic tool if you're trying to trigger the start of a recording, you're not sure when it's going to start, and we can actually put in a pre-trigger, so we're buffering the data, and then a post-trigger for how long you want to record. So we've got a little fan here, you arm the system, it starts to buffer, and then it's live. We then see the machine start, press the icon, and it's recorded the pre and post buffer. Fantastic tool. Great for things like bump tests, as we're seeing here, and then we can obviously isolate the individual frequencies. This is a filtered reading of a bump test. It's really great for capturing these transient events. Machine startup, this is a fan going through a resonance problem as it increases in speed, and then we can do detailed analysis afterwards. Really fantastic tool. Live region of interest, so this is where we can actually do a measurement in the live mode. This is really useful just to get a feeling of the different frequencies on the machine before we actually start saving recordings. So really nice, we get waveform, frequency data, we can look at the amplitude. Really useful tool, that. Long-term record, this is almost like a I think like a time lapse, so we can actually do stuff like thermal growth over many hours. So we put a duration in here. I'm going to put 180 minutes, but it could be as long as you want. And then how often do you want to capture an image? I've put 5 seconds here, but it could be minutes or hours. And then we set record, and then every 5 seconds in this case it's going to take an image, which will build a video, which we can then look at the data. And here was a turbine warming up, it was offline, and we're doing some thermal growth measurements over a long period of time. I think it was 2.5 hours. And then we can actually play the video, and the one on the right shows you the machine rocking backwards and forwards as it heated up, and there's the thermal growth measurements. We've also got the option now, if we've got a couple of ROIs, we can actually get measurements off those. And just like before, we can go into the waveform, but this time we can actually do what we call a difference plot. So we've got two thermal growth measurements there, or distances. We overlay, we go to a difference plot, lots of different options there. We click that, and then it shows the difference between the 2 points on how much movement has occurred. Really nice tool, that. Really nice. This is a big favourite of mine, use it all the time, high density recordings. So the standard MA is really good, but sometimes with a frame rate it might be slightly jerky. So with this we can take an ROI, get a frequency, and then actually if we go into filtering, it's just another filtering method this. We go into HDR, and then the key is we're going to lock into the frequency of interest. We're then going to add that to the system, and then I like to put probably 8 to 10 cycles, which is sort of the rotations. Apply that, and then that's going to process that, and now we're going to have a HDR recording, which is really, it's like super smooth, and you really see that extra detail. You can see the difference on the left and right. Fantastic tool this, highly recommend using this. Here's some examples. Great for vectors as well. The vectors, really smooth vector motion. We can see a pump here. So much detail when these have been HDR'd. Really cool. You just see the subtlety of the motion. Audio recordings. Let's go for the amazing colour camera, which it's just got so much impact, I feel. I'm still going to use the black and white, but where needed I'll use the colour if I just want that extra sort of communication, really, because it really does jump out at you, the colour MA. You can do recordings on there the same as before, measurements, it's absolutely not a problem. The only slight thing, indoors you will need a little bit of extra light, but that is not a problem, and we've had some fantastic results with the colour camera. It really is amazing stuff. Next one is TAC-Sync. This is amazing. So we're using an external TAC. This is an add-on to the system, back into the camera, and it's going to actually trigger a data capture every revolution on rotating component. Now you do need a bit of reflective tape on the component of interest, and as we see here, I've locked into this fan. The TAC's pulling in the data 2200 RPM, and then I can actually set a number of cycles, frames to capture. So we could just, it does need quite a bit of light, this, so I do recommend you use external lights, and then we record the data and it's just capturing the reading every revolution. Now here's a coupling, this is rotating, and what we're doing here, that's the standard video, we're going to amplify it now, and we can actually see the coupling flexing. So this is the non-synchronous frequencies we're looking at. It removes the one times, okay? This is a fan impeller. We can see there's a little drill there. Absolutely amazing. I'm looking forward to getting some industrial shots for this, but truly amazing. Phase map. So this is another cool tool. So we've got a bridge structure here. It's vibrating. We can see there's some motion there, but with the phase map we can actually use, it's like a 360 degree color of phase. So we lock into the frequency, and by color we can see what's in and out of phase, and then we can actually just highlight if we want. In this case I'm doing the 180 degrees difference in phase. Really nice tool, very visual. Here's a couple example. These are 90 degrees out of phase, these two components, and again I've just highlighted those frequencies and it overlays that colour. Got another example here. This is a motor rocking due to a bass problem, and you can see when we overlay that, real contrasting colours there. 180 degrees drive end to non-drive end rocking there, and if you add a bit of transparency you can even show a bit of the motion in the video. Stabilization, we've always had this, but there's been a great update with this, and I highly recommend when using this, you stabilize the raw data. Don't filter and then stabilize. You need to stabilize the raw data, as I'm doing here, and then filter afterwards. So once you've used the stabilization, you can see it's improved massive, but then we can filter it. So what we'd do, we'd draw an ROI, region of interest, just get a frequency off there. And then, as we normally do, quick method to get into filtering there, and we're going to filter the data just for that frequency. And apparently it's significantly improved this, and I've seen that in a few videos I've actually played with it. So great update there, definitely be using that. Audio recordings, this has been highly requested. So in Motion Studio we can do lovely video reports, and now we can narrate over the top and add audio. This is fantastic, and again it just increases the flexibility of the system. So what's great, you can do a constant recording if you want, or like I'm doing here, we're adding a couple of narrations to key points, and then you can move those about as well. I do recommend you do your full video first and then do the narration, or otherwise you can get out of sync a bit, but a great tool.